Hi, this class is about residual analysis of multiple linear regression. What you see here is our slides from residual analysis on chapter 14, but we're going to use the same slides to analyze the residual analysis in multiple linear regression. And just to remind you, this is the third video in the sequence in which I use this Butler Trucking Company case, in which we have assignments with miles, deliveries, and the total travel time. And we solved most of the problems in videos 1 and 2 of this 3-part video. And now I'm going to use the same slides of chapter 14 to analyze the residuals. Remember, we have to analyze the residuals because using multiple regression has an assumption. Simple or multiple linear regression have the same assumptions, and the same assumptions are that the errors are random variables with mean of 0. The variance of them is the same. The variance of errors is the same for all values of the independent variable, and the values of the error are independent, and the error term is a normally distributed random variable. So let's take a look at how to analyze them. So first is residual plot against the x. Remember, we have the residual. The residual, to remind you, is the difference, is the error, is the difference between my prediction and what really happened. So we want our prediction to be equal to what happened. So we want them to be 0, but that's not what happened. Okay, so let's take a look here. We have the first one is we have to evaluate if the residuals, the distance of these residuals, if they vary in the same way along all values of the independent variable. So here we have the first independent variable, miles. Okay, so we have different values for miles: 20 miles, 40 miles, 6 miles, 60 miles, and so on. Okay, so what we're looking for is kind of a similar variability along these different values of miles. Okay, so the residuals seem to vary in similar way. Okay, so for low and high values of miles, the residuals kind of have the same size. Here they have higher size, but here they have about the same size. So what we are looking is, let's see if I can insert. No, it's not here. Well, I cannot insert the figure anyway. Let me see if I can. No, oh, here, yeah. So what I'm looking for is kind of an ellipse, something like this. Okay, so let me shape, no fill. So this is what I'm looking for, kind of this. And if the residuals are distributed like this, I say that they have constant variance. The variance is constant along all values of miles. Okay, but I have to analyze this plot for all independent variables. So the second independent variable is deliveries. So let me see if I can get a I'm not too happy with this one. This one looks like I don't know, it's elongated or something. So the question is, do the residuals vary constantly along the values of the deliveries? So we have 1 delivery, 2 deliveries, 3 deliveries, 4 deliveries, 5 deliveries. I don't know. It seems that for 3 deliveries, they don't vary as much as in the same way of 2 and 4 deliveries. So I want to emphasize that there's no clear-cut decision process here. You have to look and try to see. Let's assume that it is constant. So we have constant variance. So the residuals vary constantly along the line of deliveries. Okay, it's not very clear that they don't vary constantly, but I want you to understand what you have to look for. So if there is a kind of V-shape, very strong V-shape or U-shape here, then we don't have constant variance. But in this case, let's assume We have constant variance in these two cases. So this deals with the constant variance. This deal with this assumption here. The variance is the same. This is the constant variance assumption. Okay. And this assumption of errors with a mean of 0, they will always have a mean of 0 because the model is designed to give us that, to give us. But what we can do for this one, let's reduce the decimal places here. So let's test we tested the second one. We tested the second one by looking to these plots. Okay, so we are done with this assumption. Let's take a look at this assumption. The error term is a random variable with a mean of 0. So let's get average here. So let's get the mean of residuals, or mean of errors, is equal to average. And then I select these residuals here. They have a mean of 0. Okay. So we are done with the first assumption. We are done with the second assumption. The value of errors are independent. This is more conceptual. There is no test in Excel to test that. This is more conceptual. What this means is that typically the independent variables are not correlated. Okay. I'm sorry, that's not proper to say. What this independent of errors are is that the assumption 1 and assumption 2 are independent. Assumption 2 and assumption 3 are independent. Assignment 3 and assignment 4 are independent. Assignment 4 and assignment 4. So the independence of errors is that these assignments, they don't depend on one another. Okay. So that's no test for that. That's more a conceptual. We have to think and see, is this assignment independent of this assignment? Yes, they're two different trucks. They're two different drivers, so they don't depend on one another. Okay, so there's no test for that. That's more conceptual. And finally, the error is a normally distributed random variable. So to do this, we have one test is to see if we have standard residuals higher than 2 and smaller than 2. So let me highlight those. So here, put this way. There is no standard residuals higher than 2 or smaller than -2. Remember this? Let me show you on the slides. So on the slides, we have the residual plot against the independent variable. This is the constant variance assumption. Okay. The standardized residual assumption is about the normality, the normal distribution of residuals. And what we're looking for is all the standardized residuals have to be between -2 and 2. They have to be between -2 and 2. So there is no standard residual higher than 2 or smaller than -2. This provides evidence that residuals or errors have a normal distribution. Okay? We can also select these residuals. Let me see if I can do that. Insert and see. Oh, we need a frequency distribution here. No, that's not the case. So let's, I think that basically what you have to do is look for this. And let me go back here and emphasize that if there are observations, in this case assignments, higher than 2 or smaller than -2, then we have outliers affecting the normal distribution assumption. Okay, so this is how we analyze this, and this is what Residuals must be normally distributed. Select the residuals and plot them in a scatter plot. Let's take a look at a scatter plot. This is what I was trying to do. Scatter plot. I'm sorry, I didn't select anything, so let me delete this and select the residuals, insert. So they can kind of have a kind of normal distribution here. We have to do the frequency table, but that kind of give us an idea about how they're distributed. Okay, so I'm gonna stop here, and that's all about residual analysis in multiple regression. You have to look for the constant variance, mean of residuals equal to 0, standard residuals between -2 and +2, and take a look at the distribution of residuals and see if there's something like not like too deviating too much from this x0. Okay, and that's it.